what is my alkyl group? It's isopropyl. So whereas alkyl becomes alkoxy, isopropyl becomes isopropoxy. So this is going to be called isopropoxy butane. I've got to indicate though where on the carbon backbone is the isopropoxy group, because I could have had this compound, and that could just as easily be described as a butane with an isopropoxy group. So I've got to indicate where along the backbone is the isopropoxy group. And obviously this is carbon 1, 2, 3, 4. So this compound is 1 isopropoxy butane. Let's name this compound. Major functional group, alcohol. So I'm going to write all. The carbon backbone now has a carbon-carbon double bond and a carbon-carbon triple bond. The triple bond has higher priority than the double bond. So this is going to be an in-all, but it's also an N. It's got an N and an in. Because the triple bond is a higher priority than the double bond, then so the thing with the highest priority ends up last. So all wins. When we characterize the backbone, the triple bond being higher than the double bond is closer to the end of the name. So this has 1 triple bond and 1 double bond, so it's an in-all because of the triple bond and the OH. It's an N-in-all because of the double bond, the triple bond, and the OH. Longest chain, 1, 2, 3, 4, 5, 6, 7. So it's a hept, and this time the hept is followed by a vowel, so I don't need an A. So the only time I need an A is when the like it's hept or hex or oct, and the next letter is not a vowel. Now, what are my vowels? A, E, I, O, U, and sometimes an Y. So Y would be considered a vowel in this context. So it's a hepten in all, but it's not just a hepten in all, right? Which I could. It also has a methoxy group and a deuterio group. So this is a deuterio methoxy heptenol. So what do I need now? I need locants, and I need a configuration for the carbon-carbon double bond. Obviously, I want the smaller number for the hydroxy group. So this is 1, 2, 3, 4, 5, 6, 7. And I would call this 7 deuterio, 3 methoxy, hept, 4N, 6 in, 2 all. So it's 7 deuterio, 3 methoxy, hept, 4N, 6 in, 2 all. Or 7 deuterio, 3 methoxy, 4 hepten, 6 in, 2 all. I need the configuration here, and I have H and H, so it's trans. Or in terms of priority, this beats H, and this beats H. So the groups of like priority are on opposite sides. So So I can either choose to call this E or trans, blah, 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 blah. Now, I'm not going to put 4E. Because with IUPAC, all you need is just enough to name it. And if I look at the name and there's a 4N, well then for heaven's sake, I know the double bond is at carbon number 4. So I don't need to come here and say 4E, because it says it's there in the name. But, oh, I erased it. But in the case where you have multiple carbon-carbon double bonds, you need to indicate who is who, right? Which one is E, which one is Z, and so on. So you need a locum next to the configuration when there are multiple configurations. If you only have one configuration, there's no need, right? IUPAC wants you to have just enough information, no more, because the name becomes wrong. Okay, so amines. So amines are named, so amines are RNH2, at least for a primary amine, but it can also be R2NH for a secondary amine, R3N for a tertiary amine. Okay? The way you name amines is as alcan, well, it's as alcan, alken, or alkin amine. So let's just jump in and name a couple. So that is an amine. So I'm going to write amine. I'm going to characterize the backbone. It's got a double bond in it, so it's an enamine. How long is my carbon-carbon chain? It's got 1, 2, 3, 4 carbons, so it is a butenamine. It's not just a butenamine, it's got 2 chlorines, so it is a dichlorobutenamine. I need locants and configuration for the carbon-carbon double bond. So, major functional group, so this is 1, 2, 3, 4. So this becomes 2, 3 dichloro but 1 amine. Or 2, 3 dichloro, 2 buten, 1 amine. I need the configuration. Well, it's clearly trans. So I can call this trans. 2, 3 dichloro, but 2N, 1 amine. Where it gets a little interesting with amines, so that's a primary amine. Where it gets interesting with amines is, not that that wasn't interesting, is if I have something like this. Well, it's an amine. The longest carbon chain is 1, 2, 3, 4 carbons. Did I have the same thing there? So it's got 1, 2, 3, 4, 5 carbons. So it's a pen. Oh, well, no. If I put the triple bond in, so it's got 1, 2, 3, 4, 5 carbons, but there's a triple bond in the backbone. So this is now an enamine. It's got 1, 2, 3, 4, 5 carbons. It's a pentenamine, right? The N also has a methyl group on it. Now, when there's a methyl substituent, I just normally say it's a 1 methyl something or 2 methyl blah blah blah. So if I had if I had a methyl here, for example, I would call this 2 methyl 3 chloro 2 methyl. I use a locant when the methyl is on a carbon. that's part of the chain. But when the methyl is on the nitrogen, well, it's not part of the carbon backbone, it's on the nitrogen. So I don't use a locant, I use the letter N to indicate that the methyl is on the N. So a number indicates that the alkyl group is a substituent on the carbon backbone. The letter N indicates that the alkyl group is a substituent on the nitrogen. So I would call this, there's no room here, I would call this N-methyl pentinamine. What I need now is to indicate where the nitrogen is on the backbone, right? So obviously, again, I want the end of the lowest number, the lower numbers. This is our 1, 2, 3, 4, 5. So technically, this is N-methyl 1-pentinamine. N-methyl 3-pentin 1-amine. So N-methyl 3 for where the triple bond starts, pentin 1-amine, or N-methyl pent 3-in 1-amine. If I had two methyls, I would call it N, N dimethyl, and then I'd feed here. So the N dimethyl 3-pentin 1-amine. If I have a methyl and an ethyl, since E precedes M in the alphabet, I'd call that N-ethyl, N-methyl, and I feed into 3-pentin 1-amine, right? And no, this would be a hyphen because the methyl and the ethyls are different groups. So N-ethyl, N-methyl, 3-pentin 1-amine. Okay. Okay. Then okay. Then there are aldehydes, which are RCH double, RC double H. These are called alk, A-E-Y, anals. So this compound is an aldehyde, so I'm going to write al. The carbon backbone is saturated, so it's anal, right? I use A. The carbon chain, which includes the carbonyl, is carbonyl is 1, 2, 3, so this is propanal. Now, I'm not going to put 1. I'm not going to call this 1-propanal. Because by definition, aldehydes are RC double bond OH. There are no carbons on this side. So the carbon chain terminates or starts, depends on your perspective, at the carbonyl. And since the carbonyl group is the major functional group, so in this molecule, well then it has to be carbon number 1. Right? There are no carbons here. If that's a major functional group, that must be carbon number 1. So I'm not going to say 1-propanal, the 1 is superfluous. So this is simply propanal. What if I had this compound? if I have that compound? So this is my major functional group here is an aldehyde. So I'm going to write al. I'm going to characterize the backbone. It's got a triple bond and a double bond. The triple bonds win. So this is an in-al, or an, because I'm going to write the in closer to the al, and then the n next. So this is an N-al. Longest carbon chain. 1, 2, 3, 4, 5, 6, 7. So this is a hep 10-enal. It's not just a hep 10-enal, it's got deuterio, iodo, and now what do I do with this? When the OH was the major functional group, it was king, it appeared in the base as all. Well, what happens when it's not a major functional group? The answer is, it's just a substituent, and it's a hydroxy group. So OH is hydroxy. I had it in the board earlier. So this is a deuterio dihydroxy iodide. And the alphabet is D, then H, then I. So this is a deuterio dihydroxy iodo heptenenal. Locants, carbonyl must win. So it's 1, 2, 3, 4, 5, 6, 7. And this would be 1 deuterio. And by the way, if this were T for tritium, it would be 1 tritium. Right? Why don't we just do that? Because we did a deuterio one earlier. Let's just make this T. So this would be a tritio. So this would be a tritio. So this would be 1 tritio. Four, 7 dihydroxy, 3 iodo, hep 2N, 5 in al. I do not need a locant for the al. If we're an aldehyde, we are carbon 1. If it's got a double bond, I'm looking out for EZ or cis strands. I can't use cis strands because none of the groups on either carbon are replicated on the other carbon. So cis strands doesn't work. So in terms of priority, I beats carbon, carbon beats H. So the groups of like priority on the same side, this is Z, 1 tritio, 4, 7, dihydroxy, 3 iodo, hep 2N, 5 enal. I don't need a locant for the Z because there's only one carbon-carbon double bond, and I know where it is. It's a position number 2. Adding a second 2 makes it superfluous. Isn't this fun? Then there are ketones. So ketones are R2CO. In other words, they are C double bond O R, and they are called alk A-E-Y O. So they're called alkanones, alkenones, or alkinones, depending on the character of the backbone. So if I have this compound, it's a ketone, I'm going to write O. The backbone has only carbon-carbon, carbon-carbon single bonds, so it's an anode. It's 3 carbons long, so it's a propanone. Do I need a locant? Let's see. Right now, the carbonyl is on carbon number 2. So do I call it 2-propanone? Well, what's the alternative? Is there an isomer of this compound? Because the point is you want to name it so that no two compounds have the same name. So the alternative is I move the carbonyl to either that carbon or to this carbon. But if I do, it's no longer a ketone. In fact, these are the same thing. It's an aldehyde. That's propanol. So if a 3-carbon species with a carbonyl has the carbonyl on carbon number 2, that is the only version of the ketone that we can have. Because any other position, there's only one other position, is no longer a ketone, it's an aldehyde. So that's just propanol. The number is superfluous. What if I had that compound? Right? What if I have this compound? If I have this compound, what would I call that? Well, it's an one, it's an anone, and it's got 4 carbons. So that's butanol. Does it matter? Do I need to give a locus? Is it 2-butanol? Okay, well, if I put the carbonyl group here, that's the same thing. If I put it here, it's not an aldehyde. I put it here, it's an aldehyde. Therefore, I don't need a locus. That is just butanol. There is no other isomer, right? That's a problem we have with these. So I could end up with these OH groups in any number of places in this compound. The iodine could be any number of places. So I need to put locants for those, because if I move them, the compound changes. Nothing like that happens there, right? If it's going to be a ketone, there is no other place for it to be but here, with 3 carbons. If this is going to be a ketone, there's no other place for the carbonyl to be but here. And this are the same position. So the first time I will need a locant is when we get here. Right? So that compound is 3-pentanol, which is very different from this compound, which is 2-pentanol. Okay? Name that one. One, enone. 1, 2, 3, 4, 5, 6, 7. 8. So it's octenone. Y is sometimes a vowel, so we're good. It's not just octenone. It's got an amino and a hydroxy. So it's an amino, hydroxy, octenone. I want the carbonyl to have a lower number. 1, 2, 3, 4, 5, 6, 7, 8. So this becomes 5 amino, 4 hydroxy, oct, 6 in, 2 O. Okay? Okay? 4 more. So, RCO2H is a carboxylic acid. It's RC11OOH. They're called AEY-oic acids. 2 words. So they're called either alkanoic acids if the carbon backbone is saturated, alkanoic acids if they've got a carbon-carbon backbone, carbon-carbon double bond, or alkinoic acids if they've got a carbon-carbon triple bond. So just, OH. So this would be, right, I'm going to write oic acid. My backbone is saturated, so it's anoic acid. It's got 1, 2, 3 carbons in it, so it's propanoic acid. And we're done. I don't need a locant. Because if I'm a carboxylic acid, there are no carbons on this side. And as a major functional group, I win. I'm carbon 1. So there's no need to say 1 propanoic acid. What do I call this? So it's oic acid. The backbone has 2 carbon-carbon double bonds, so it is dianoic acid. 2 words. 1, 2, 3, 4, 5, 6, 7 carbons. So it's hept. Here's my problem. 2 consonants. Heptadianoic acid. It's got 2 bromines and a hydroxy, so it's dibromo, hydroxy, heptadianoic acid. Locants, 1, 2, 3, 4, 5, 6, 7. So we are 5, 6, comma. We are 5, 6 dibromo. 7 hydroxy, hep, 3, 5, dianoic acid, hepta. So it's 5, 6 dibromo. 7 hydroxy hepta 3, 5 dianoic acid. I need configurations for the 2 double bonds. This could be called trans. Well, yeah, that'll work. So I could either call it, so this would be trans, H here, opposite sides of the double bond. And this one would be cis, because the bromines are on the same side. So I can call this 5 cis, well, I can call it 5 cis, 3 trans, no, the other way. I call it 3 trans, 5 cis, right, because I want the small number regardless of the letter. So 3 trans, 5 cis, 5, 6 dibro, blah, 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 blah. Or, in terms of E and Z, this would be E, and this would be E. Or I could call it 3E, 5Z. Well, actually, with these, I don't put a locant. I don't put a hyphen. So that's 3E, 5Z. Blah, 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 blah. If I had this compound, I would call that oic acid. So it's an oic acid. My carbon chain is saturated, so it's anoic acid. It's got 1, 2, 3, 4, 5 carbons, so it's pentanoic acid. It's got a carbonyl at carbon 1, 2, 3, 4. So this IUPAC allows a couple of things. You can call it 4-oxo or 4-keto. So either one is allowed. So I'm going to call that 4-keto or 4-oxo. So there wouldn't be a hyphen here. So that'd be 4-oxo. They would join the name. So 4-oxo pentanoic acid or 4-keto pentanoic acid. And similarly, if I had this compound, it would be called 1, 2, 3, 4 4-oxo. Yeah. So this would be 4-oxo butanoic acid. Or I might call it 4-aldo butanoic acid. If I had this compound, I'm going to write oic acid, but I've got 2 of them, so it's a dioic acid. I've got 1, 2, 3, 4, 5 carbons, so it's pentan. And what normally happens is you put an E in. So it's called pentane dioic acid. So with the oic acids, you put an E. With the dioic acid, you put an E. So it's pentane dioic acid. Yeah. Okay. We just do 2 more really fast. So there are esters, and esters are R, C double bond O, O R prime. These are also 2 words. They are alkyl, 1 word,